Alright, just working some more on some trig integrals. I got some different methods that could potentially be used to help us with these. So we're just going to kind of work through some examples today in class here. So the integral, the indefinite integral of sine x times cosine to the 6th x dx. What are your thoughts on how we might go about doing this? Integral by parts. Could, potentially. Would u substitution just work here?
No.
Yeah.
Which one would you have be u?
Cosine.
Cosine? So u is cosine, so what's du?
Wait, is that a
Or negative sine x.
Negative sine x dx?
But doesn't that only work if it's like on the inside, like if... Never mind. I'm off.
Couldn't you just make sine u so it doesn't negative?
Do you want your du raised to the 6th power?
Yeah, you don't want du raised to the 6th. In this case, we can raise our u to the 6th.
Wait,
That
what
makes
is being raised? Is it after the x or is it?
No, it's cosine to the 6th.
You don't have to put that
Same
in
thing.
u?
It's the same as cosine x in parentheses to the 6th power.
Does that make sense?
Yep.
Okay. So then what do we really have here?
A
We have
negative.
u to the 6th, du,
Negative 1
and throw a negative sign right out in front, or negative all the way in front. Is that the same thing then?
Yeah.
Okay, yep, very good. This is pretty simple here. Antiderivative of negative 1 u to the 6th.
1 7 u to the 7.
Good job.
Thank you.
And then substitute back. Negative 1/7 cosine to the 7th x plus c.
And just to double check, cosine to the 7th x is the same as if you have cosine x in parentheses to the 7th?
Yes.
Good.
Okay on that one?
Yeah.
Alright. Let's try a little tougher one here. This is one that I have not worked out myself, and hope it goes okay.
This is where
Hmm?
this we have the u and v on
I don't believe so, but I mean, we can take that approach here. I don't think that's how we're going to get there, but
So I was just thinking that because like cubed and
sure. So then, what do you want to be your u, and what's your dv?
That's the easiest way to
Want
do
du to be.
I mean, I think we're going to go a different direction with this. I don't think we're going to do integration by parts.
But listen,
Did
there's a
you
different
have
direction.
two u's? No, that's not the best way to say it. Never mind. So I was thinking if maybe it's...
Sine squared plus cosine squared equals 1. Pythagorean identity for trig. So, what I'm thinking is I'm going to let u equal cosine x, du equal
Negative sine x.
negative sine x dx.
Why?
So then I have u to the 4th
And then
negative u to the 4th du,
sine
and then I'd still have a sine squared x because I was shooting to get this down to a sine squared is what my goal was gonna be. Yeah, to use the identity, because now I'm gonna replace sine squared with 1 minus cosine squared.
Oh.
You sly dog.
Which wouldn't then that just be 1 minus u squared? Because cosine is your u. I'm going to move that to the front here.
And then distribute, I'm guessing?
Mm-hmm.
So it would just be negative.
So my goal was, when I saw this, was to do it similar to how I did the last one. The problem was, if u is cosine x, du is negative sine x, but I still have another sine squared in that. And therefore, I could use the identity that says sine squared is really equal to 1 minus cosine squared, because then I could have everything in terms of cosine squared, which would therefore let me have everything in terms of u. And if you can get everything in terms of u, then you're able to find the antiderivative a little bit easier. Okay, so I'm going to distribute this now. That'd be negative u to the 4th plus u to the 6th du. And that would then be negative 1/5 u to the 5th plus 1/7 u to the 7th plus c. And then I could substitute back negative 1/5 cosine to the 5th x plus 1/7 cosine to the 7th x plus c. Questions on that?
So, I guess, like, looking at that, were you just teaching us when you see that, you think of the identity, or is there something that you just knew?
You could have potentially used the identity right away and replaced, we could have thought of this as sine squared x times sine x, and then replace that sine squared with 1 minus cosine squared right away. And then from that kind of turn everything into terms of u. But
That way, it seems easier.
sure. This is a very common identity. You'll use it a lot. Sometimes the reason it's helpful is because it can get sines in terms of cosines or cosines in terms of sines. And if you can get everything alike, doing the antiderivative is so much easier. Right? 7 tables fine. Okay?